Today we're talking about section 7.5. It's entitled Sample Spaces. So we are going to go back and apply this to probability. So we are going to kind of go back to probability, but for now, sample spaces, we're just going to talk about what those are, how to define them, and how to find them. So first we need to discuss what is a sample space. A sample space is the set of all possible outcomes in a situation. So for instance, if I were to roll a die, there are 6 sides of a die. The sample space would be 1, 2, 3, 4, 5, and 6. So those are all the possible things that could happen would be the sample space. So we're going to go ahead and go through some examples of how to find the sample space. We're going to go through 2 different methods. The first one's going to be making a list of just all the possible outcomes. And the second one will make a tree diagram. So similar to what we did when we did prime factorizations, we're going to kind of go back to that here in a little bit. So first example. 3 students chosen to represent Mr. Baldrick's class in a school assembly are shown. All 3 of them need to sit in a row on the stage. How many different ways can they sit in a row? So we have Adrian, Carlos, and Greg. And so we want to know how many different arrangements can we do so that we have all 3 of them sitting in a row. And we want to know how many different possibilities or options there are. So all we're going to do is make a list. I'm going to use A for Adrian. I'm going to use C for Carlos. And we use G for Greg. So we're going to have those 3 letters. So the first way that they could do it is just the way they are. A, C, G. So that's one possible way. Then maybe we keep Adrian first, but let's switch the other 2. We have Greg and Carlos. That's another way. So now let's switch it. Let's put Carlos first. And then we'll put Adrian and then Greg. Or if we start with Carlos, we go to Greg, and then Adrian. Then let's put Greg first. So we have Greg, and then Adrian, and then Carlos. Or we have Greg, and we have Carlos, and we have Adrian. So all I did was I put each one of them first, and then the other 2 just kind of switched around. So how many options do I have? I have 1, 2, 3, 4, 5, 6 options. So this is my sample space. These are all of the top. So it says in how many different ways? There are 6 ways. We've just listed them all. And there are 6 ways that they can all arrange themselves in a row on the stage. So that's the first way to make a list. Second way would be to make a tree diagram. So what is a tree diagram? Again, a tree diagram is just a way that you can list all of the events one after the other. So it's kind of like making a list, except we're just going to do it kind of using branches of the tree instead of doing each list like we just did. So it says use a tree diagram to find how many ice cream cones are possible from a choice of a waffle cone or a sugar cone and a choice of chocolate, mint, or peanut butter ice cream. So to do this, what we do is we set up our options. So I say, okay, for my first option I have the cone. We either have a sugar cone or I have a waffle cone. So I set up my 2 different options. Then opt for the sugar cone. How many different types of ice cream can I choose? Well, there are 3 different options, right? I can have chocolate, I can have mint, or I can have peanut butter. But I can also put those same 3 with a waffle cone. So I could have a waffle cone with chocolate. I could have a waffle cone with mint. Or I could have a waffle cone with peanut butter. So it says, use a tree diagram to find out how many ice cream cones are possible. Essentially I have a sugar with chocolate, sugar with mint, sugar with peanut butter. So this is option 1, option 2, option 3. Then I have a waffle with chocolate, a waffle with mint, and a waffle with peanut butter. So that would be options 4, 5, and 6. So again, we have 6 options. Now both of these examples lead us to what we call the fundamental counting principle. Because notice, I had 2 options here, and 3 options. So I had 2 cone options and 3 ice cream options. 2 times 3 is 6. If I go back to the previous example, we had, that's a different one. Ignore that one. So what we're going to do is the fundamental counting principle, which tells us if I have m options for one thing and n options for another thing, we simply find the total number of ways by taking m times n. So for the cone, I had 2 options. For the ice cream, I had 3. So 2 times 3 is 6. So I'll leave that up there for a second so you guys can go ahead and copy that down. Go ahead and pause it if you need more time, but I'm going to go ahead and move on. So our last example asked us about Casey's Pizza House. And it offers 3 types of crust, and it offers 6 types of toppings. So they want to know how many different types of one-topping pizzas we could have. So we want to use the fundamental counting principle. So for the crust, how many options do I have? I have 3. We're not asking what it is, we're just asking 3. And then for the toppings, we only want 1 topping. How many toppings do I have? 1, 2, 3, 4, 5, 6. 6, what do I do with these 2? I multiply them. 3 times 6, not 16. 3 times 6 is 18. So I have 18 choices for a 1-topping pizza. And it's as simple as that. You're just multiplying 2 numbers. Now, if I wanted to know what are all of my options, I could create a tree diagram. I could say, okay, I have the hand-tossed crust, and then I have 6 toppings choices. Then I have the thick, and I have 6 choices. And then I do thin with 6 choices. And you could list out all of your 18 choices. So you're going to practice this a little bit on your homework, which is page 391, 4 through 22, all of them. And so they're all going to be, a lot of them are all word problem types. But a lot of them you're either doing, the first part of it, you're either doing lists or tree diagrams. And the second part of it, starting with number 12, you're just using the fundamental counting principle, which is nothing more than multiplication.